Welcome to Department of EEE. My name is Professor Bhubaneswar, Assistant Professor in Department EEE. Today I am going to perform an experiment, that is a PN junction diode experiment. In this experiment we will do here two things. One is a forward bias condition, other is a reverse bias condition. And we will take the readings. Simultaneously we will draw a graph between I and B, that is current and voltage.
So this is a PN junction trainer kit. Also we can call as a semiconductor diode characteristic apparatus, or also we can call as a combination equipment. Why combination equipment? Because in this equipment we have a voltmeter attached, a ammeter attached, two toggle switches, input output ports, and here we have two diodes. One is for forward bias, other is for reverse bias. Also there is a DC battery over here, and it is a one type of controller. Okay. Now here the toggle switches we can set as on and off. Here for 10 milliampere, for 100 microampere. This is for 3 volt DC, 30 volt DC. Okay. So now see that this trainer kit we can use for both forward bias of PN junction diode as well as also reverse bias of PN junction diode. Now just see that. Now here we have two options. One is the 3 volt DC, other is the 30 volt DC. Now if I move the toggle switch to 3 volt DC, so what happens? We have to take the readings of this voltmeter and the upper scale. You can see the upper scale 0 to 3 volt. Okay, so we'll take the reading from 0 to 3 volt. Now if I move the switch down towards 30 volt DC, we have to take the readings from 0 to 30 volt, downscale reading. Similarly, if I move the switch to 10 milliampere, I have to take the reading from 0 to 10 milliampere over the upper scale reading. Now if I move the switch to downside, that is 100 microampere, I have to take the readings from the downscale reading 0 to 100 microampere. So if I move the switch upside, it will become 10 milliampere reading. If I move the switch downside, it will become 100 microampere reading. Okay, accordingly we'll take the readings. Now it's also, if you make that switch to upside 3 volt DC, we'll take the readings from the upper side, upper scale. If 30 volt DC, we'll take the reading from the downscale. Okay, so today the aim of the experiment is here to test the performance of PN junction diode. That means we have to perform the experiments in two ways. One is a forward bias, other is a reverse bias. Okay, so before going to discuss the experiment, we need to know what you mean by biasing. So biasing means connecting the PN junction diode to any external DC source. Right? Okay. So first of all, we'll do the diagram of circuit. Suppose this is your PN junction diode. Okay. So this side is your P type, this side is your N type. Okay. Now if I talk about first forward bias, that means I have to connect P type to positive terminal of the DC source and N type to negative terminal of the DC source. Got it? So forward bias means I have to connect the P type terminal, P type the material to the positive terminal and N to the negative terminal. Okay. Now in this case I have to also connect here ammeter in series with this circuit. Why? Because here we in this equipment we have a ammeter is there, also we have a voltmeter is there. For ammeter we have to connect here ammeter in this series, and for the voltmeter connection I have to connect a voltmeter across the circuit. Okay, so two things I have connected over here. Now we'll show this circuit diagram in terms of this equipment. Okay. Okay. Now, so this is for the forward bias. So this is the PN junction diode. So for the forward bias, I have to connect the P terminal. This is your P side, this is your N side. I have to connect the P terminal to the positive supply of the DC battery. Where is the positive supply? Here. This is the positive supply, the DC battery. Okay, so P type I have connected to positive supply. Similarly, I have to connect the N type to negative. But before that I have to connect a ammeter in series. So I have to connect this one to first positive terminal over here. Then I have to connect the negative terminal to the negative terminal of the DC battery. Okay. Again check it. P type I have connected to the positive terminal of this one, and N type I have connected to ammeter, and negative terminal of the ammeter I have connected to negative terminal of the battery. Okay. Now in order to connect the voltmeter, I have to connect the voltmeter over here parallel across. Okay. So I have to connect the voltmeter positive to positive, and voltmeter here negative to negative. Now circuit is purely complete. Now with the help of this controller, I can vary and I can obtain the corresponding value of voltage and corresponding value of current over here. Okay. Now initially I have to set the voltage at 3 volt DC. Why 3 volt DC? Because for forward bias I have to connect for the 3 volt DC, and I have to take the reading from the upper scale reading 0 to 3 volt. Similarly for forward bias I have to set the toggle switch to 10 milliampere, so I can get the reading from 0 to 10 milliampere for the upper scale reading. Okay. Now let us connect the power supply. Okay. Okay. Now in this case I will just close it. In this case I will vary the variable voltage. Suppose this is a point, suppose it is 0.5. So I'll take the readings here. Little bit current deflection is there. Again I'll vary, suppose to 1 volt, and you will see that there is also variation of a current, suppose here 2 milliampere. So simultaneously I will vary the voltage, and I will see there is also a variation of the current over here. So I will take readings of both this voltmeter plus ammeter. So suppose I will take multiple readings of voltmeter and ammeter, and I will draw the graph between your voltage and current. That is called as an IV characteristic. Okay. So you can see that I have taken different readings of voltage plus its corresponding readings of current. So I have taken here 8 number of readings, and I got 8 values of forward voltage and 8 values of forward current. Now I will draw a graph between this voltage and current. Here you can see, so you can see that clear that I have drawn the graph between voltage and current. So this is the VI characteristic of a PN junction diode in case of forward bias. Let's take a close view. Okay, now we'll do the connection for reverse bias condition. For reverse bias condition, we have to set the voltmeter terminal to 30 volt DC and for the ammeter to 100 microampere. Okay. Now we'll do the connection. So this is the diode connection for the reverse bias condition. This is the P type, this is the N type. So connect the P type connection to the negative terminal and connect the N type to the positive terminal. Okay, but before that I have to connect the ammeter in series. So I have to connect the series. I have to connect this one to the negative terminal and the ammeter and positive terminal to the battery positive terminal. Okay, now similarly I have to connect the voltmeter across, so plus to plus and here minus to minus. Okay, my circuit is purely complete. Now in this case I will vary the voltage slowly step by step until I get a deflection in the ammeter. Okay, now let's switch on the power supply on. Now vary slowly until you get different values of current over here. Okay, see that? Okay, so we have to take different readings of voltage with corresponding different readings of current.
Okay, so finally we have obtained the VI characteristic in case of forward bias and reverse bias condition of PN junction diode. Thank you all.